Hello, today we are going for discrete Fourier transform. Now, why we are going for the discrete Fourier transform? We will discuss here what is the use of discrete Fourier transform and what are the drawbacks of discrete Fourier transform. Along with, we will learn the definition of DFT and inverse discrete Fourier transform. Okay. Now, up till now, we are dealing with the continuous time signal. Now, along with the continuous time signal, we will also study the discrete time Fourier transform. Okay, in our signal and system, we learn about the Fourier transform. Okay, so the discrete Fourier transform will provide a method to represent a discrete time signal in frequency domain and to perform frequency analysis of discrete time signal. Getting this? Okay, main intention of the DTFT is to provide a method to represent a discrete time signal in frequency domain and to perform frequency analysis of discrete time signal. But the drawback of the DTFT is that the frequency domain representation of discrete time signal often using DTFT will be a continuous function of omega. Getting my point? Again, I am repeating. The domain representation of discrete time signal often using DTFT will be a continuous function of omega, and so it cannot be processed by digital system. So because of this drawback, we will turn toward the discrete Fourier transform. Now, the discrete Fourier transform is shortly represented as DFT, capital DFT, and it has been developed to convert a continuous function of omega to a discrete function of omega. What is the purpose of DFT? DFT purpose is to convert a continuous function of omega to a discrete function of omega, so that the frequency analysis of discrete time signal can be performed on a digital system. Okay, then it is possible to perform any kind of analysis over the digital system. So this is the biggest advantage as compared to the continuous as well as discrete time Fourier transform. That's why we turn toward the DFT. Now we see here the definition of DFT. So we discuss it, but before that, remember DFT of a discrete time signal is obtained by sampling the DTFT of the signal at uniform frequency interval, and the number of samples should be sufficient to avoid aliasing of frequency spectrum. Getting this sentence? Okay. So here the sample of DTFT are represented as function of integer k. Now here k is used as an integer. So here some conventions are utilized for describing the DFT signal. So here k is used as a integer signal representation. So the DFT is a sequence of complex number represented as x of k. Okay, so here capital X of k is used for representation of a discrete Fourier transform, and here the value of k will be lies between 0, 1, 2, 3 and so on. It will be dependent upon the length of the discrete time signal, whatever the discrete time signal that which we use here. Okay, over that the length of the discrete Fourier transform is dependent. Now here remember x of k is a sequence consisting complex number. Okay, it is a complex number, remember the magnitude and phase of each sample can be computed, and it is listed as a magnitude sequence and the phase sequence. Remember, okay, it is a complex number, so that's why here it carries the magnitude and phase, and these magnitude and phase of each sample can be computed, and it is listed as a magnitude sequence as a and phase sequence. Okay, now we will learn in practical how you can plot it, the magnitude as well as the frequency spectrum as well as the phase spectrum. Okay, we will learn it in our problems also. I tell you how you can able to find the magnitude and the phase spectrum of a discrete Fourier transform signal. Now, last point that I have to tell you here, the drawbacks. The drawbacks of the now the drawback of DFT is that the computation of each sample of DFT involves a large number of calculation. Okay, so remember, what is the drawback? Here, computation of each sample of DFT involves a large number of calculation, and when a large number of samples are required, then the number of calculations will be increases. So, to overcome this drawback, we will go for another algorithm. Okay, but for this time, we will discuss how you can use the DFT, how you can understand the DFT and IDFT. So, for this time, I am telling you here the definition of DFT. Now, what is the definition of DFT? What it carries? What parameters are present? So here, let x of n is a discrete time signal. Remember, x of n is a discrete time signal and it has a length, that is L. Okay. Similarly here, when you are representing a discrete Fourier transform, then the discrete Fourier transform is represented by a capital X of k. So we will say a discrete Fourier transform is the discrete Fourier transform of x of n is directly proportional to the discrete Fourier transform. So here we will write shortly DFT of x of n is defined as x of k is equal to summation of n is equal to 0 to n minus 1 x of n e raised to minus j 2 pi nk by n. Okay, what is the definition? Here, x of k is represented as a DFT and x of k is directly proportional to summation of n is equal to 0 to n minus 1 x of n e raised to minus j 2 pi nk. Okay, here frequency term is coming with the our summation term and discrete signal. So here the value of k is represented as 0, 1, 2 up to n minus 1. Okay, so here the discrete time signal is represented with a length. Okay, and from this length we will calculate a discrete Fourier transform. Now this is about the definition of the discrete Fourier transform. Now we will go for here the inverse. DFT, inverse discrete Fourier transform definition. Now the definition of the inverse discrete Fourier transform is a small x of n, means we will get a original discrete time signal from the discrete Fourier transform. So that's why here the x of n is represented as our discrete time signal, and it has a length. That length will be achieved from the DFT signal. Okay, now the DFT, whenever we find out the DFT, that time from that length we will find the value of k, that will be 0, 1, 2 up to n minus 1. Now we will go for the revert process. So for this reversal process, here we will get a original discrete time signal, that is x of n. So x of n is defined as 1 by n into summation of k is equal to 0 up to n minus 1 x of k, capital X of k, into e raised to, now here instead of minus, remember most of the students are doing mistake here. Here they write minus sign, so here the sign is positive. J 2 pi nk, j 2 pi nk by n. Okay, so in this definition, remember here 1 by n term is multiplied. Okay, so it tells you here the length of a sequence, that is length of the DFT sequence. Okay, it will get divided, and summation of k is equal to 0 to n minus 1 x of k e raised to j 2 pi nk by n. Here the value of n is varying from 0, 1 up to n minus 1. Okay, so this is a way of definitions of the inverse discrete Fourier transform. Okay.